Alright, these are also momentum problems, and they're slightly different than the ones we did in the last set. Main difference is, well, we'll see. So we'll set up before and after, just like before. Before and after. And let's see, first thing is there's a car hitting a truck. Okay, so we have a car, and we've got a truck. And each of those has a mass, a velocity, and a momentum. But this time, when they crash, they stick together. So after, we're only going to have one column. It's the car/truck mashed together. So in some ways, these are actually easier because you have one less object. So we've got the mass of the car, which is 1,200. We've got the mass of the truck, which is 1,500 kilograms. Together, they crash into each other. Their masses combine, so they will be 2,700 kilograms. And they will have the same velocity. So the car is moving right at 30 meters per second, hits the truck moving left, that's going 25, so negative 25. So we're going to find their momentums. So the car is 1,200 times 30, or 36,000 kilogram meters per second. And the truck is 1,500 times negative 25, or negative 37,500. So their total momentum together, if we add them up, is negative 1,500 kilograms meters per second. And since there's only one object after the crash, that must have the same momentum, negative 1,500 kilogram meters per second, because we don't have to divide it up amongst two objects. So, negative 1,500 equals 2,700, the mass, times v. And then we just solve for v. And I get negative 0.56 meters per second. This is the v. Negative 0.56. So that means that after crashing into each other, they continue to the left, because it's negative, at 0.56 meters per second. This should make sense because the truck had more momentum than the car. So when they crashed, there was enough momentum to keep it going left, not to the right. And that's why this worked out the way it did. Alright, let's try another one. It's similar. We'll set up our before and our after. So before and our after. So we have a cannon, and it's loaded with a cannonball. So before, you've got a cannon and the cannonball probably sitting inside the cannon, MVP. And then it fires it, so the cannon is now by itself, and the cannonball is out on its own. So before, the total mass of them together was 1,050 kilograms, the cannon plus the cannonball. They were just sitting still, so they were 0 meters per second. So the momentum of them was 0. Now after it's fired, they are going to each have their own mass, velocity, and momentum. And according to this, the cannonball, which remember has a mass of 50 kilograms, the cannon was 1,000. The cannonball is fired to the right at 35 meters per second, so positive 35. So the momentum of the cannonball was 1,750 kilogram meters per second. Now, the momentum before was 0, so that means the momentum after must also be 0, and the only way that's possible is if the cannon were negative 1,750, because negative 1,750 and 1,750 is 0. So then we can find the velocity of the cannon. Negative 1,750 equals 1,000 times v. And when we divide, you will get negative 1.75 meters per second. So that is how fast the cannon is recoiling. It's going to go to the left at 1.75 meters per second. So the cannon has equal momentum as the cannonball, just in an opposite direction. And it's going slower than the cannonball because the cannon's much more massive. So this is very similar to the recoil problems we did with Newton's third law, just basically doing it another way. So anyway, until next time, I am Derek Genova. Have a delightful day.